You'd like to save some money and you think you've come up with a really good idea for doing it. Every month, on the first of the month, you put some money in the bank. And if you do that every single month regularly, by the end of the year, you'll have quite a bit of money saved up. And it'll be pretty painless to do it just a little bit every single month. If only there were a way to save money that way. Well, as it turns out, there is a way to do it. It's something called an annuity. With annuities, the deposits into the annuity are made at regular intervals. So in our example, that was once a month. And the deposits are the same amount of money over the term of the annuity. So for as long as we're going to be saving money, we will put the same amount of money into the account regularly. When we're working with annuities, we're going to have a pretty complicated looking formula to use. In the formula, A is the annuity's future value. That's how much it's worth at the end of its term. Capital R is the regular periodic payment. So that's how much we're depositing in the annuity on regular intervals. Lowercase r is the annual interest rate, written as a decimal. N is the number of payments per year. And T is the term of the annuity in years. That's how many years we're going to be investing. So let's look at an example. Suppose we want to find the future value of an annuity if we deposit $50 every month for 3 years and the annuity pays 2% annual interest compounded monthly. So in our formula, the capital R is $50. That's the regular payment. Lowercase r is 0.02. That's our interest rate. N is 12 because we're making payments monthly. That's 12 times a year. And T is 3 because we're investing for 3 years. Now let's substitute those values in the formula. We get something that looks like this, and we need to remember 2 things as we work with it. First of all, use order of operations as you simplify. And secondly, don't be tempted to do any rounding, not until the very last step. So, as you work through this, hang on to all those digits after the decimal point until you finally get down to one single number. Now you want to simplify this by rounding to the nearest cent, that's the nearest hundredth, and we find out that at the end of 3 years, we will have $1,853.51 in our annuity. Now let's look at one more example. And in this case, we're not trying to find how much is in the annuity at the end of time. We're trying to find out how much we have to deposit in the annuity to reach a goal at the end of the annuity's term. So we want to know what's the regular payment that we need to make in the annuity if the annuity pays 4% compounded quarterly, and we want to have the future value of the annuity be $1,000 in 2 years. We're still using the same annuity formula, but in this case the unknown is the capital R. We don't know what the regular payments are. So when we substitute the values in the formula, we still need to remember to use order of operations and to hang on to all those decimal points. But we're trying to solve for the capital R. So we're going to have to think more like solving for an unknown value in algebra. We're undoing some operations. When we finally get to this step, we're going to be dividing both sides by that number that is multiplying the R to isolate the R. And the R is our regular payment. So now we can take that number and round it to the nearest cent. and we get a regular payment of $120.69. That means if we deposit $120.69 in this annuity 4 times a year for 2 years, at the end of 2 years we will have $1,000 saved up.